lesson, we will learn about another Java collection framework class, which is HashMap. So what is a HashMap? A HashMap stores key value pairs. So it will have a key, and against the key it will store values. And a key stores one value. So against one key we will have one value in a HashMap. The keys are unique. So the keys in a HashMap are unique. So example, where can we use a HashMap? So for example, a telephone directory can be easily stored in a HashMap where key is what? Phone number. So the key is the phone number, and what will be the value? The name of the person whose phone number it is. And note that against one phone number we will have only one value, and the phone numbers will be unique. So in a telephone directory we do not have the same phone number for two people. So the keys are unique and we store one value against a key. Another example would be login details, which is username and password. So what will be the key here? The key here will be the username, because usernames are unique, and against a username I have one password, and the value is obviously the password. So let's look at how do we use hash maps. So let's start with this example. So what do we do here? We are defining a hash map telephone directory. So the same example that we were talking about, telephone directory, teldir is a hash map, and because it stores two values, the first one refers to the type of the key and the second one refers to the type of value. So here this is a hash map in which the key is of type string and the value is of type string, and we have created a new hash map called teldir. Now how do we put values into a hash map? We use the method put. The method put takes two parameters, the key and the value. So the key here is this telephone number 95821-67401, and the value against it is Edufect. Similarly, we are putting another value into it. 98237 is the key and John is the value, and we are putting 37856 as the key and William as the value. So we have put three key value pairs in this hash map. Then how do we determine the size of a hash map? We use the method size. So the same method we used in array lists and hash set. So size will tell us the number of key value pairs in the hash map. And here in this class, what are we doing? We are printing the size and the hash map. So what do we get? So the size, as we expected, was 3. And then the hash map is storing three key value pairs. So against the key this, we have the value Edufect. Against the key this, we have the value John. And against the key this, we have the value William. Let's see if we, in the same code, try to put another value into it. So notice in this case, we are using the same key. 95821-67401 is the same as this. So they are the same. And instead of Edufect, we are making it Edufect Institute. And we are also putting this key 30012 with the value Steve. Okay. Or let's make it say Steve. So value Steve. And then we are determining the size of it and the printing the hash map. So let's see, let's run this code and let us see what will happen. So we know what happened till here. We got a size of 3 with these three values. We saw it. Now when we are putting this value and here this key is getting repeated, what will happen is that because a hash map has only unique keys, so the value against this key is getting replaced. So when we print it, what is it showing? It is showing that against this value, against this key, the value has changed from Edufect to Edufect Institute. So in some sense, the value got updated. So against this key, when we use again put, value gets updated. And this key 30012 was not present earlier. So a new key got created and we got a new key value pair in this hash map. And when we take the size of it, the size became 4. It became 4. It did not become 5. Why? Because this key, the value got updated. No new key got created. So this has 4 keys value pairs now. Okay. So is that clear? Let's move to another property or method of hash maps. So we have learned how to put values into it. We have learned how to calculate its size. Now suppose we want to find out against a telephone directory against a number, what was the name. So let's look at first here this example and then we will do that. So here is a hash map employees wherein against each employee ID we are putting a name. So employee IDs are ints, so which is why the hash map, because it takes only objects, we are putting an integer comma a string wherein the key is of type integer and the value is of type string. Okay, remember we cannot use int here because it expects objects. The same thing we did in array list and hash set. So we are putting these values, say 104 comma James, 114 comma Bill, 204 comma Julia and 255 comma Steve. And when we print this, we get these four values. Okay. So 114 equal to Bill, 104 equal to James, 204 equal to Julia and 255 equal to Steve, which are the key value pairs here. Now how do we get, suppose for ID 114 we wanted to get the employee name. So we will use the method get and we will give it the key value, the value of the key for which we want to find the value. So we gave it the key 114 and it found the value which we have stored in name, and when we print it, it prints Bill. Suppose we wanted to find it for employee number ID 255. So against employee ID 255, what is the value in the key value pair? Steve. So when we run it, it gives us Steve. Suppose we run it for a value which is not there. So let's take a value 201. Is 201 here? No. So when we run it, what will happen here? What will be the value of the, what is the value we get? The value we get in that case is null. So against a key, if that key did not exist in the hash map, we get the value null because the key did not exist. Suppose I change this value to say 289. 289 also does not exist in the hash map. So what do I get? I get null. Okay. So here we got the value. Now is there a way I can check whether a key is there in a hash map or not? Yes. So the way we would do that is using containsKey. So containsKey helps us to find out whether this hash map contains a key which we have provided in the parameter. So here in the same example, the same values, if we do containsKey 114, it will return a boolean. And what will be the boolean in this case? It should be true because this key exists there. And when we print it, we get this output. True and the value of the value stored against 114, which is Bill. Suppose we put another value, say 158, and we wanted to find out whether it contains the key and what is the value stored against it. And when we run it, what should we get here? We should get false because this key does not exist in the hash map, in the hash map ems, and this we should get null. So what do we get? We got false and we got null as we expected. Let's go back to the telephone directory that we were talking about, and suppose now here we get string name is equal to teldir.get, and suppose we give the value of the 958216741, and then we do system.out.println name. Now when we run it, what should we expect we will get? We should get the value against this key. What is the value against this key? The value against this key had been updated to Edufect Institute. So the print here is Edufect Institute. So this is a way we can store key value pairs and we can search for a value against a key. In the case of a hash map, the search for a key is very, very fast. The same property we saw in a hash set. So a hash map is used to store a lot of key value pairs wherein we can look up the key very fast and retrieve value to it. So in most, say, login systems, telephone directories, we will use a hash map. Now let's check for another thing. Can the key or the value be null? Let's see here in this case, we have put against the key 229 the value null. So what do we see here? When we run it, we get the value null in this. We get null as the value for the key 229. So it means we can have the value as null. Suppose we put the key as null. Now is a key null key allowed in a hash map? And suppose the value we put against it is no value. Okay, because we wouldn't want an employee with the ID null. Now let's see what will happen here. Does it allow a null value for a key? Yes, it allows a null value for a key. So we got against the key null, we got the value no value. Can we make a pair like null comma null? Would that work? Let's try it. Let's see what will happen. So we got null equal to null. So in a hash map, the key or the value can both be null. Okay, so there is no constraint here. Is that clear? So when do we use a hash map? We use a hash map to store key value pairs, as we talked about it, and like we talked about, to search for a key and find the value associated with it. And like hash set, searching is very fast in hash map. So in hash map, searching for a key is very fast, and because we can search for a key very fast, we use it to store a lot of like login credentials. We will use it to store employee databases. We will use it to store telephone directories, because if we look at say a Google or a WhatsApp, when we log into it, it's got a billion users. So we need very fast ways to retrieve them. So a hash map is a kind of a structure we would use there. Points to remember about a hash map. We talked about this. Keys are unique in a hash map. So there can be only one key of one type. Keys are unique. We cannot have duplicates in the case of keys. Values can have duplicates. So in a hash map, we can have duplicate values. We did not see an example of it. Let's look at an example. Suppose here against 255, we have suppose two employees named Bill. So what do we get? So 255 ID is also an employee named Bill, and 114 is also an employee named Bill. And when we run it, what do we get? Let's see the output. So against 114 key, we had Bill, and against 255 also we have a Bill. So we can have values which are duplicates, but the keys cannot be duplicate. And we remembered, whenever we put a key that existed, the value will get updated. Searching for a key is very fast in hash map. Very important. Very important property of a hash map, that searching for a key is very fast in hash map. And key and value in hash map can both be null. So the key can be null and the value can also be null in a hash map. Okay. So is this clear?